This next section deals with stoichiometry and limiting reactants. We didn't really do a whole lot with limiting reactants in your first year course. We did a lot with stoichiometry. And stoichiometry basically means that you have a chemical reaction, which in order to start any of these problems, you have to have a balanced chemical reaction. Then you take what you've been given, and then you've got to do the proper dimensional analysis and conversions until you get to the amount of thing that you're asked for at the end. A lot of times what you're given is in grams, and so remember that you can't ever do anything just with grams because a balanced equation always gives us relationship in moles, so you always have to convert it to moles. So you're going to take the grams of the given, convert it to moles of the given. Then from moles of given, then you're going to use the coefficients in the balanced equation to get to the moles of the asked for, and then you can use the molar mass to get to grams of the asked for. So hopefully all that comes back relatively quickly. We did that a lot in first year chemistry, so that should be easy for you by now. This section though is on limiting reactants, and while you have heard the comment in your first year course, you were never expected to figure out what the limiting reactant was. So basically, what is a limiting reactant? Well, basically what that means is that you have one reactant that's going to run out before the rest of them. So if you're making chocolate chip cookies and you have lots of flour and lots of baking soda and lots of sugar and lots of salt, but you have a very limited amount of chocolate chips, then once you run out of chocolate chips, you can't make any more chocolate chip cookies. You might be able to make sugar cookies or something else, but without chocolate chips, you can't make chocolate chip cookies. So when you run out, then you can't make any more. And that's going to be the same thing that's true here. Once I run out of one of my reactants, then that limits how much of the product I'm going to be able to make. Now, I'm going to show you three different methods for finding the limiting reactant in a problem. He shows you two of them. I'm going to show you a third one. It doesn't matter to me at all which one that you choose. The only thing that matters to me is that when you're working the problem, that you make very clear this one is the limiting reactant. This is the calculation that I did. This one's the limiting reactant. This is the one that I used. Okay, so the first method that he shows you is a method that I call, we're just going to do it by inspection. We're just going to do it by looking. And so the problem that I'm going to use to explain this one is example 1.9, where we have an equation where I'm reacting P4 plus Cl2 to make PCl5, which he says is an important ingredient in certain insecticides, so that's why we're making it. And he says we're going to start out with 10 grams of P4 and 30 grams of Cl2. How much PCl5 can I make? Well, in order to do that, the first thing I got to do is I've got to figure out which one of these is the limiting reactant, which one is going to run out first. Now, you might initially think that the P4 is going to run out first just because it has fewer grams, but remember, this doesn't give me a relationship in grams, it gives me a relationship in moles. And so I have, before I can do anything else, I've got to convert both of these things to moles using my molar mass, okay? So I get 0.0806 moles of P4, I get 0.429 moles of Cl2, okay? So therefore, that means the P4 is going to run out. I was right, yes? No, not necessarily, because if you look at the balanced equation, this says that for every 1 mole of P4, I need 10 moles of Cl2. Okay, so that means that with the amounts that I have, I've got to have 10 times as much Cl2 as I do P4. Well, my P4, I have 0.0806. If I multiply this by 10, that would give me, if I multiply this by 10, that's going to give me 0.806 moles of Cl2 that I would need in order to completely react with everything that I have here. Do I have 0.806? No, I only have about half of that amount. I don't have that much. And so therefore what that tells me is that this Cl2 is going to be my limiting reactant. It's going to determine how much product I can make. So again, I want to really make this very, very clear. Even though I had fewer grams of P4, even though I had fewer moles of P4, that still wasn't my limiting reactant. The limiting reactant is based on how much I need from the chemical equation, and the reaction tells me I need 10 times as much of this as I do of this, okay? I don't have it, so therefore the Cl2 is the limiting reactant. Once you have that, then you're gonna go through, you're gonna convert your grams to moles, which you've really already done. You're gonna use the mole ratio from the balanced equation, then you're gonna convert moles of PCl5 back to grams using that molar mass, and you will end up with this answer right here, okay? So again, this part down here should be a piece of cake for you. This should be easy. This is the tricky part, and that's determining the limiting reactant. When you are working these problems, please make sure, and you don't have to use a different color, but just please make sure that you indicate this guy is the limiting reactant, and that's what you're going to use. Okay, so that's one way to work the problem, is just looking at it and going, okay, I can reason this out. This is going to be the limiting reactant because I don't have, however much I'm going to need. So by inspection is by doing it one way. For some students, that is a very difficult way to go about doing these problems. Students who are super strong in doing math in their heads, a lot of times can do it that way. The other thing that happens is, even if you are strong in math, sometimes you get some real wonky ratios here, and it makes it a little bit more difficult to do in your head. So if this is too difficult, we got two other methods I can show you, okay? So the next method, I'm going to use exercise 1.10 part 1, because they had two problems within that one. And that's by actually calculating how many grams of product you'll get with each one. This is a much longer way to do it, but you're probably less likely to make a mistake when you do it this way. When you do this, here they give you a reaction where you are reacting calcium hydroxide with acetic acid, CH3COOH, to make calcium acetate with that. And what he tells you is you've got 10 grams of each reactant. How many grams of product can you make from it? To use this method, you simply say, well, I got 10 grams of this reactant. How much product can I make? And so you're going to set up your dimensional analysis, and you're going to go through and you say, okay, if I start with 10 grams of calcium hydroxide, I can make this much product. If I start with 10 grams of acetic acid, again, you're going to set this whole thing up again. I can make this much product. Well, which one's smaller? This one's smaller right here. So that means, since this number is smaller, that's going to be the amount that you can make, because your acetic, or your CH3COOH, that's going to be your limiting reactant. So you'll see again, I'm marking this one is my limiting reactant, so this is going to be my final answer. All you have to do is pick the smallest number. Is it a little bit more work? Yeah, but you're probably less likely to make a mistake unless you're super, super good at being able to inspect this and figure it out that way. There is a third way, and so I'll show you that method next. The third method is by looking at a mole to coefficient ratio, which is really almost what we're doing over here, but there's an additional mathematical step to make it a little bit simpler to see. Okay, so in the second part of the problem, this is on page 18, it says that we've got, gives you your balanced equation there. You've got 50 grams of FeTiO3, you've got 100 grams of HCl, and you have an excess of Cl2. So at least he was nice to you there, and he gave you an excess of one of them. You knew one of them was an excess, but I've got two others that I don't know which one's the limiting reactant, and I want to know how many grams of that TiO2 I'm going to be able to make. So once again, I've got to figure out the limiting reactant. In this method, you still have to start by taking your grams and converting it to moles. And remember, that's always something that you're going to have to do, because your balanced equation relates moles and not grams. So once I take both of the reactants that he gave me and I convert it to moles, now what I'm going to do with this is I'm going to divide these number of moles by the coefficient that's in the balanced equation. So if you look at the balanced equation, the FeTiO3 on the left-hand side has a 2 in front of it as a coefficient. So I'm going to take 0.330, I'm going to divide it by 2, and I'm going to get 0.165, okay? The HCl, which I calculated, I've got 2.74 moles of that. In the balanced equation, the HCl has a 4 in front of it. So if I take 2.74, divide it by 4, that gives me 0.685. So really what that's telling me is that if I wanted to run the equation, if I wanted to run the reaction according to the coefficients that were there, what that says is that I got about 16.5% of this amount that I would need. Here, I've got 68.5% of what I would need. So this number is smaller right here. So therefore, that means that this FeTiO3 is going to be my limiting reagent. Okay? The FeTiO3 is limiting because the mole to coefficient ratio is smaller. Once I have that figured out, then I can take that number of grams of FeTiO3, set up my my dimensional analysis down here. I'm going from grams to moles to moles to grams, and I'm going to get a final answer of 26.3 grams. Okay? One thing that I do want to mention here too is that a lot of times when he does these problems, he'll do this piece in a step, then he'll do this piece in a step, then he'll do this piece in a step. Nothing wrong with that. You can do that. But what you're going to find is that the more times that you round, the more it's going to end up affecting the answer. So if you do these problems the way I'm doing them, where you're stringing all these numbers, all these calculations together, don't be surprised if your answer comes up just slightly different from his. Now it's going to be not going to be a lot different, but the answer that I got is 26.3. On a similar problem, you might look at the answer key and say, oh, he got 26.7. Okay, so the last digit may be a tidge off, but it's just going to be the last digit, and it's just going to be by a little bit. If the number's way off, then your answer's wrong, okay? So make sure that you really aren't rounding any more than you need to. If you're doing the same operation, if it's all multiplication, then I would put that in the calculator and just keep right on plowing. I wouldn't keep rounding at each particular step. Okay, go all the way through, then round when you get down to the end, to the proper number of significant figures. Okay, so either by inspection, or you can actually calculate how many grams of product you'll get with each and pick the smaller one, or you can do a multi-coefficient ratio. Whichever multi-coefficient ratio is the smallest is going to be your limiting reactant. Doesn't matter to me which way you do it. In fact, you may have some problems that are pretty easy and you can do them by inspection. Then you may have others where you can't see it as easily, and so then you'll use one of those two methods. So any of those ways is fine, but you'll get some practice figuring those out today.